Hello. Welcome to Visionaryx, our podcast where you can have real and simple conversations with us about various tools and technologies. I'm MongoDB, and
I'm MinIO. In this podcast, we dive into exciting discussions about simple and deep technical topics in the world of DevOps and cloud. You can find the full transcript of this episode on our website, visionaryx.tech, to follow along with us. Stay tuned and enjoy the adventures in the world of technology.
wow. Look at MinIO's new changelogs. They made list objects better. It uses the disk well now. They have new batch expiration for objects, outside caching for metadata, and use WebSockets for internal communication. They made ILM and replication better too. They can now fix settings in sites. They also use small archives for batch replication. This can make things work much better. Nice new changelogs. But let's talk about the start. Hey MinIO, let's talk about object storage. First, why do we call an object an object?
That's a deep question, MongoDB. This idea is about how digital data works. At the lowest level, everything is just bits, zeros and ones. An object is really a string of these bits.
That's right. And these bits are usually put in groups of 8 called bytes, right?
Exactly. And the interesting thing is, this string of bytes has no meaning on its own. We only know what these bytes mean when we use special rules to understand them.
That's a very important point. So can we say that an object has no meaning by itself?
Exactly. An object is just a data structure that has a set of bytes. The meaning of these bytes only becomes clear when we use a special algorithm or agreement to understand them.
That's interesting. So when we say format or type of an object, we're really talking about these agreements.
Absolutely right. The format and type of an object are really agreements for understanding this string of bytes. Without these agreements, an object is just a string of numbers.
That's a very deep view. Now, let's talk about the inside structure of an object. What parts does it usually have?
Usually, an object has 3 main parts: header, payload, and sometimes footer. The header usually has information about the structure and content of the object. The payload is the main content of the object. And the footer, if it exists, is usually used for extra information or checksums.
And this structure lets us store different kinds of data, right?
Exactly. And this is one of the main benefits of object storage. We can store different types of data without needing to know what's inside. Object storage systems just work with strings of bytes and let the apps figure out what the bytes mean.
That's a very important point. Now, let's talk about metadata. This is a big part of what an object is, right?
Absolutely right. Metadata keeps information about the object. Like how big the file is, when it was made, what type of content it is, and so on. This helps us get important information without having to look inside the object.
So we can say that an object in object storage usually has 3 main parts: data, what's in the file; metadata, information about the file, and a special ID.
Exactly. This is a standard definition that most object storage systems use. But we should remember that some systems or theory models add other parts too.
Like what?
For example, some systems think of version as a separate part. Or sometimes access policies are seen as part of the object itself. Even checksums are sometimes added to this list.
Interesting. And I think this variety in definition shows how flexible this idea can be.
Exactly. And this flexibility is one of the main reasons object storage was made to solve problems with storing unstructured data on a big scale.
Now that we're talking about the philosophy of object storage, can you tell me what its main idea is?
The main idea of object storage is to make it easier to manage and access lots of data. This approach lets us manage data as separate units, without needing a complex tree-like structure.
And this makes object storage perfect for certain situations, right?
Exactly. For example, it's great for storing static data that doesn't need to change often, or for data that needs to be accessed through HTTPS.
That's interesting. Now, let's talk about the features of an object. For instance, I've heard that objects are usually unchangeable, immutable. Is that right?
Yes, that's one of the important features of objects. Usually, they can't be changed after they are made. This feature helps us keep data consistent and whole.
And what about scaling?
Scaling is one of the main strengths of object storage. We can store from a few kilobytes to many terabytes in one object. This flexibility in size makes object storage good for many different uses.
And I think another important feature is being able to access it through RESTful APIs, right?
Absolutely right. This feature makes working with object storage easier for developers and makes it simpler to connect with other systems.
Well, this discussion was really deep and interesting. I think we now have a better understanding of the basic ideas of object storage.
I agree. These are the basic ideas that all object storage systems, including you and me, are built on.
Well, this talk was really deep and interesting. But I have one more question. Where does the idea of object in object storage come from?
That's a good question. Actually, this idea comes from object-oriented programming, or OOP. In OOP, an object is an example of a class that mixes data and behavior together.
Interesting. So how did this idea move to the world of storage?
When this idea came to the storage world, we still work with the idea of mixing data and metadata. An object in object storage, like an object in OOP, keeps its information and descriptions together.
This similarity in ideas is very interesting. And I think this approach gives us many possibilities, right?
Exactly. This approach lets us be very flexible in managing and storing data. Now that we're here, we can talk about how different systems use this idea in different ways.
I agree. For example, in GridFS we use this object idea to store big files, but with one key difference.
What difference?
We use MongoDB's abilities to split big files into smaller chunks. This lets us use MongoDB's good things like complex queries on metadata.
Interesting. We at MinIO have a different approach. We use a special object storage system called erasure coding that's made to store and get big objects quickly. Erasure coding lets us store data in a spread-out way, which makes things safer and work better. Also, we use a spread-out design that lets us grow sideways, which means we can easily add more storage space by adding new servers.
That's right, and this difference in approach has a big effect on how these systems are used. For example, with GridFS, we can use all the power of MongoDB's query engine to search metadata.
I agree that this ability can be useful in some cases. But we also have strong APIs for managing objects that are made for object-focused operations.
True. But think about a system that already uses MongoDB. With GridFS, they can use the same data model and tools to manage big files. This integration can be very valuable.
I agree that this integration can be an advantage. But what about scaling? This is one of the main challenges in object storage.
I'm glad you asked that. Using MongoDB's sharding ability, GridFS can scale well. We can spread data across many servers and still have the benefits of atomic transactions and strong consistency.
These abilities are certainly interesting. But don't forget that at MinIO, we use a spread-out design that lets us add new nodes as we need. This lets us easily reach petabyte scale and even more.
Good point. Each of us is best for specific cases. For example, GridFS is perfect for cases that need to mix structured and unstructured data. We also provide data streaming, which is great for multimedia apps.
True, and we're best for cloud-native cases and very large-scale storage. I think the important point is that each of us has our own place.
I completely agree. In the real world, choosing between GridFS and MinIO depends on the specific needs of the project, the current setup, and long-term goals.
That's right. And I think this variety in solutions is ultimately good for users and developers.
It certainly is. In the end, our goal is to provide the best solution for managing and storing data, whether it's with GridFS, MinIO, or any other system. Let's do a real comparison between GridFS and MinIO for object storage. GridFS uses MongoDB's internal structure, letting us store and get files bigger than 16 megabytes. We split files into smaller chunks and use two collections for storage, one for chunks and one for metadata.
True, and at MinIO we use a special object storage system made for this job. We use erasure coding to spread data and have a flat structure for storage.
The important point is that GridFS uses MongoDB's query abilities. This lets us do complex queries on metadata, which can be very useful for some use cases.
True, but we have S3 compatible APIs that are familiar and standard for many applications.
Yes, but we shouldn't forget that GridFS gives better integration for systems already using MongoDB. We can use the same data model and tools to manage big files.
I agree. But what about scaling? At MinIO, we have a spread-out design that scales easily.
GridFS also scales while using MongoDB's sharding ability. We can spread data across many servers and benefit from atomic transactions and strong consistency. We're like a really efficient moving company, except we move data, not furniture.
True, but we should note that we're optimized for cloud-native scenarios and very large-scale storage.
Yes, but GridFS is ideal for scenarios needing to mix structured and unstructured data. We also provide data streaming, which is great for multimedia apps.
What about data security and encryption? At MinIO, we support server-side and client-side encryption and use role-based access control (RBAC).
GridFS also benefits from MongoDB's strong security features. We support advanced authentication and authorization, SSL, TLS for communications, and at-rest encryption. Plus, we can use MongoDB's field-level security features. We're like a digital Fort Knox, but instead of gold, we're guarding your precious data.
Interesting. What about backup and recovery abilities?
GridFS uses MongoDB's strong backup methods. We can do time-based and incremental backups and use point-in-time recovery. Also, using replica sets, we can ensure high reliability.
We also have strong backup abilities in MinIO. This includes incremental backups and versioning that lets users get back older versions of objects.
What about working with monitoring and management tools?
We work well with standard monitoring tools like Prometheus and provide strong management APIs.
For monitoring, we also have open-source solutions. For example, there's MongoDB Exporter for Prometheus that can collect GridFS metrics. This tool lets us watch important metrics like the number of files, data volume, and query performance. Also, MongoDB itself has internal APIs like db.serverStatus that can be used to make custom dashboards.
What about speed of data access, especially for big files?
GridFS uses smart indexing and chunking to provide quick access to specific parts of big files. This is very useful for scenarios like video streaming. We're so fast, we could probably stream a movie before you can say popcorn.
At MinIO, we also use advanced techniques to improve data access. Our multipart upload and ranged GET requests make fast and efficient access to big files possible.
Another important point to consider is flexibility in data structure. GridFS has high flexibility in metadata structure because it uses MongoDB's data model.
True, but we also have strong abilities in metadata management at MinIO. Users can add custom metadata to objects and use them for searching and filtering. We're so flexible with metadata, we could probably catalog a library's worth of books about rubber bands.
Thank you for listening to Visionaryx. You can find more technical and practical discussions on our website visionaryx.tech.
Next time, we'll be talking about Nginx.
Goodbye for now.
Goodbye.